Taken in 1990, this photograph is one of humanity's most unforgettable images looking back at Earth. A lonely, pale point of light suspended in the endless darkness of space. The photo Carl Sagan called the pale blue dot. But this frame didn't just remain a historic photograph, it was also a major turning point. Because shortly after this photo was taken, Voyager 1's cameras were turned off forever. And since that day, for 36 whole years, we haven't seen a thing. Today, Voyager 1 is at the farthest point humanity has ever reached, a full 24 billion kilometers from Earth, heading through the darkness into interstellar space. What's more, it is still communicating with us. Even today, we continue to benefit from the scientific data it sends. So, if Voyager is still working, why were its cameras shut down? And even more importantly, if Voyager 1 could open its eyes again today, what would it show us in that endless darkness? Voyager 1 wasn't actually a crazy project conceived out of nowhere. Everything began in the early 1970s when astronomers noticed something extraordinary. The giant planets of the solar system were entering an extremely rare alignment, occurring only once every 176 years or so. This was no ordinary alignment. A spacecraft launched at the right time could use the gravity of the planets like a slingshot to gain speed, reaching the next one with almost no fuel. Such an opportunity might come along only once in human history. Naturally, NASA didn't pass it up. Launched in 1977, Voyager 1's primary mission was clear: to study Jupiter and Saturn up close. And it accomplished this with far greater success than expected. Jupiter's massive storms, Saturn's mesmerizing rings, and Titan's thick atmosphere were revealed to humanity in detail for the first time. Many iconic images we still see today in textbooks and documentaries were captured for the first time thanks to Voyager. Yet, all of this was really just the beginning of the story. As Voyager 1 passed Saturn, it got a final boost from the planet's gravity, and its course changed completely. A journey of no return had begun. Flung above the plane of the solar system at roughly 61,000 kilometers per hour, the probe headed where no human-made object had ever gone before. And years later, in 2012, a new chapter opened in the history of space exploration. Voyager 1 passed the boundary where the Sun's influence ends, becoming the first human-made object to reach interstellar space. Today, nearly 50 years after its launch, it is still continuing its journey, quietly alone, roughly 24 billion kilometers away. Yet, the interesting part is that while Voyager's scientific mission continues, the cameras that made it our eye on space were turned off long ago. But before understanding why the cameras were shut down, we need to clear up a major misconception. Because when picturing Voyager's camera, most of us unknowingly imagine today's technology, as if it carried high-resolution digital cameras. However, Voyager 1 was actually launched in 1977. That means there were no digital cameras, no smartphones, and no CCD or CMOS sensors we use today. Voyager's cameras relied on a very different technology. They used Vidicon imaging tubes, similar to the technology found in old CRT televisions. It might sound surprising, but the craft we sent into deep space actually resembled an old TV camera, far more than modern digital cameras. Even stranger, these cameras couldn't take color photos directly. When Voyager 1 took a picture, filters like green, blue, or ultraviolet rotated in turn in front of the camera, and the probe took several black and white photos of the same target through different filters. Those images were then combined back on Earth, producing the famous color Voyager photos we're all familiar with. So, in reality, none of those iconic pictures were single-shot color photos taken by the probe. Of course, capturing the image was only part of the challenge. The real problem was transmitting them to Earth. Today, we can take a picture on a phone and send it across the globe in seconds. For Voyager, the situation was completely different. Every image taken was converted into radio signals and sent across billions of kilometers of space to reach Earth. What's more, Voyager is now roughly 24 billion kilometers away from us, causing its data transmission speed to drop dramatically. For comparison, at this rate, even a 1 megabyte file would take around 14 to 15 hours to arrive. Today, we transfer millions or billions of bits of data per second on the internet. Voyager, by comparison, is barely whispering. Because of this, sending a single photo can take hours or even days, depending on the camera settings. In short, taking a picture with Voyager was far from as simple as tapping a screen on our phone. Every single frame was immensely valuable in terms of time, energy, and data capacity. And that is precisely why engineers at NASA had to make a choice. Either keep the cameras on and drain the craft's power within a few years, or turn off the cameras, which had fulfilled their purpose, forever, redirecting the remaining energy to scientific instruments so Voyager could keep transmitting data for as long as possible. Because Voyager was no longer anywhere near Jupiter or Saturn, there were no new planets left to photograph out there, nor any gas giants with majestic rings to capture. Ahead lay only the vast, endless darkness of interstellar space. Meanwhile, the remaining functional instruments could continue gathering valuable scientific data that humanity had never been able to measure before. Where exactly does the sun's influence end? What is the magnetic field of interstellar space like? How do cosmic rays behave out here? These were the questions NASA wanted to answer. Behind this entire decision was a simple yet harsh reality: energy. Right now, Voyager 1 is so far from the Sun that solar panels are useless. It relies entirely on an onboard nuclear power source known as an RTG. This system converts heat from the natural radioactive decay of plutonium into electricity. Of course, this power supply isn't infinite. Year after year, its power output steadily declines. The cameras alone consumed 40 watts of energy, a massive amount of power under Voyager's current operating conditions. That is why all of the cameras were shut down, but even that wasn't enough. The complex software code controlling those cameras was entirely erased from Voyager's tiny memory. In its place, new code was loaded for scientific instruments designed to analyze interstellar space. What's more, the electric heaters keeping the cameras warm were also turned off completely. So Voyager's cameras have been literally frozen in temperatures well below -50 degrees for nearly 36 whole years now. In short, even if NASA wanted to turn the cameras back on today, there is neither the power left to run them nor the software code to operate them. That is why Voyager's eyes were closed, never to be opened again. Now, let's consider that compelling question. Suppose a miracle happened. What if we solved the power problem, reloaded the software, warmed up the hardware, and clicked the shutter? In that very first photo sent back from 24 billion kilometers away, what would we actually see? Most of us would probably picture something quite similar. After all, Voyager is outside the solar system. Perhaps unseen stars, colorful nebulae, or a breathtaking view humanity has never discovered before. You would naturally think that traveling this far into the unknown would instantly reveal all the secrets of the universe, wouldn't you? Reality, however, is completely different, because that very first photo reaching Earth would likely be almost entirely pitch black. Yes, that's all. You might spot a few faint stars off in a corner, but otherwise you would see an empty void, spanning not just miles, but billions of kilometers wide. It really makes you pause and wonder, how could humanity's most distant spacecraft, having reached all the way to interstellar space, see nothing at all? The answer lies in the sheer scale of space. The vibrant, colorful gas clouds, giant galaxies, and brilliant sights we see in movies make outer space look packed and crowded. In reality, celestial objects are separated by unimaginably vast distances. So no matter how far Voyager has traveled on a cosmic scale, it is practically still in the exact same place. Does a dark photo mean there's absolutely nothing where Voyager is right now? That is actually the most fascinating part of all. The region where Voyager is now traveling is one of space's most intriguing boundaries. It has crossed far beyond the protective, invisible bubble of the Sun that spans billions of kilometers across the cosmos. Scientists call this fundamental boundary the heliopause, the border where the Sun's magnetic influence finally ends. Don't think of it like a national border though. There is no physical wall or sharp line where everything changes in an instant. It is a massive transition zone where charged particles from the Sun collide with matter from interstellar space. Voyager is traveling right through this region. Intriguingly, if human eyes could see ultraviolet light instead of just visible light, that dark picture would look like a giant cosmic battleground. Here lies an invisible structure scientists call the hydrogen wall. As mentioned, solar particles continuously interact with interstellar hydrogen atoms in this region. As a result, these hydrogen atoms emit ultraviolet light at very specific wavelengths. So this vast region, which appears pitch black to the human eye, actually glows with invisible light. Unfortunately, Voyager's cameras were simply not designed to capture this kind of light. Even if they were fully functional today, it is highly unlikely they could send back an ultraviolet photo showing this faint cosmic glow. Although darkness surrounds Voyager, there is still one remarkably bright object in the sky: the Sun. Yes, even though it is about 160 times farther away than from Earth, the Sun hasn't vanished entirely. Of course, it no longer looks like a giant glowing disk, but it still shines like a brilliant single star, hundreds of times brighter than a full moon on Earth. And for that very reason, one of the most intriguing photos Voyager could possibly take today might not actually be possible. Because there is really one image we would all love to see: Earth. Naturally, one wonders, if Voyager were to point its camera back toward us today, could we actually see that iconic pale blue dot once more? Unfortunately, most likely not. From Voyager's distant vantage point, Earth appears so incredibly close to the Sun that imaging it would require pointing the camera almost directly at the Sun itself. Even that historic photo taken back in 1990 involved taking an enormous calculated risk. NASA engineers carefully planned the shot to prevent intense sunlight from damaging the sensors. Trying that today would be even harder, because Voyager is much farther away now, and at this incredible distance, Earth would appear far too tiny, easily lost in the Sun's glare. Even if camera resolution were sufficient, intense glare from the Sun would completely overpower that tiny dot. So in all likelihood, we couldn't see our home planet. Besides, even if everything worked, images captured by a probe traveling at 61,000 kilometers per hour for well over 45 years would hardly be crystal clear. Due to cosmic dust, micrometeorites, and radiation, the lenses are likely scratched and degraded. Meaning, even if we took a photo, we'd likely end up with a blurry, spotted image. Another fascinating point is that people often assume the positions of the stars and constellations would look completely changed from Voyager's perspective. However, that is simply not the case at all. Although 24 billion kilometers away sounds staggering to us, the nearest star, Proxima Centauri, is still nearly 40 trillion kilometers away. So the immense distance Voyager has traveled over the decades is practically negligible when compared to true interstellar distances. Think of it like taking a few steps in Istanbul. Would the city's skyline change? That's why, from Voyager's vantage point, the arrangement of the stars remains virtually identical. In the coming years, Voyager's aging nuclear power supply will no longer generate enough electricity to power the probe. The scientific instruments will shut down one by one, followed by its transmitters severing its last link to Earth forever. Yet this is not the end for Voyager. Carrying human sounds, music, and our location in the universe on its golden record, it will drift into eternity through the pitch-black void.